the results of his work. Can you please charge your dissertation? Metto di lato perché tanto dopo esco. Così va bene, ok. Okay, you can speak now.
Good afternoon, everybody. Today I'm going to present my defense presentation for my PhD thesis under the title Synthesis of Nitrogen Heterocycles by Intramolecular Cyclization of Alpha-Beta Unsaturated Nitro Compound using vanadium complex as a catalyst and carbon monoxide as the reductant. This work was done under supervision of Professor Fabio Ragaini. This presentation consists of 5 main topics. The first one is introduction to reductive carbonylation reaction. Our research group are interested in studying reductive carbonylation reaction, which use the reductive ability of carbon monoxide to reduce the commercially available nitro compound and converting them into other nitrogen functionalities which are more valuable, such as amines, isocyanate, carbamate, ureas. And as we see from this scheme, the initial nitro compound in presence of carbon monoxide and metal catalyst undergo complete deoxygenation reaction, affording the highly electrophilic and the highly reactive nitrine species, which can be hydrogenated in presence of water, affording amine, or it can be carbonated by carbon monoxide, or in other words, can be trapped by carbon monoxide, affording isocyanate. And if isocyanate is formed in presence of alcohol, it would be transformed into carbamate, while if isocyanate is formed in presence of amine, it would be transformed into ureas. In addition, this reaction can be terminated either by dimerization of the nitrine species affording azobenzene, or by coupling between the nitrine species with nitroso intermediate, which come from partial deoxygenation of the initial nitro compound affording azoxybenzene. Recently, the scope of reductive carbonylation reaction is extended to include CH amination by nitro compound as the nitrogen source. As we can see here in this scheme, if there is a suitable functionality also in nitrobenzene and in presence of carbon monoxide and metal catalyst, a variety of heterocyclic can be prepared, such as indole, carbazole, benzimidazole, benzimidazolone, and so on. The second topic in this presentation is synthesis of indole. Indole is one of the most important heterocycles present in nature, especially present in the skeleton of tryptophan. Tryptophan is one of the essential alpha amino acid which is used as building block for build-up protein. Also, indole derivative and analog of indole are known to exhibit a variety of biological activity. For example, this trisubstituted indole act as anti-cancer drugs, while indomethacin, which is tetrasubstituted indole, act as anti-inflammatory drug. At the same time, serotonin, which is disubstituted indole, act as neurotransmitter agent. So the chemistry of indole, the synthesis and reaction is still a hot topic in the literature. In 2005, Davis Group published a synthesis for indole starting from orthonitropstyrene in presence of palladium acetate as a catalyst and presence of carbon monoxide. In this method, the nitro functionality is reduced to nitroso group, which aminate the CH of the olefinic group, affording N-hydroxy indole. Then by further reduction, it converted to the final indole. This work has many advantages like mild condition, excellent yield, tolerant to variety of function group, but at the same time there is a limitation for this work, which is long reaction time, and the main limitation is the need to use also disubstituted arene. In basic organic chemistry, it is known that also disubstituted benzene are prepared as a minor product from electrophilic aromatic substitution reaction. So use of, in general, disubstituted arene is not convenient in organic synthesis. Several years ago in our research group, while they were investigating intermolecular amination of cyclohexene using beta-nitrostyrene as aminating or nitrogen source in presence of carbon monoxide and ruthenium catalyst. In order to prepare this amine, which contain enamine moiety, which is easily hydrolyzable by water, affording cyclohexenyl amine as a target product, but actually no intermolecular amination for cyclohexene occurred at all. Instead, intramolecular amination occurred for beta-nitrostyrene, affording 2-methyl indole. And at that moment, our research group realized that they discovered a new strategy or new route to indole, starting from mono-substituted benzene rather than also disubstituted benzene. Later, Dong group published a quite similar strategy to indole, starting from beta-nitrostyrene, having an aryl group at alpha position. Despite the good yield and mild condition for this work, but it is limited only for synthesizing 3 aryl indole. So we established a new method or new route for synthesizing indole, starting from beta-nitrostyrene, and the reaction condition or the reaction parameter for this work was optimized by other members of our research group, namely Dr. Muhammad Hagar and Stefania Molto. I want to thank them. And really this work has the advantage of using mono-substituted benzene and also easily prepared substrate. Concerning the preparation of the substrate, beta-nitrostyrene having a substituent at beta position were prepared from their corresponding aldehyde by Henry condensation with nitroalkane. While beta-nitrostyrene having a substituent at alpha position were prepared from their corresponding ketonimine by condensation with nitromethane. Using this two simple strategy, we were able to synthesize a variety of substituted nitrostyrene. Concerning the scope of the reaction, we applied our optimized reaction condition to a variety of differently substituted nitrostyrene, and we obtained indole from fair to excellent yield. As we can see from this slide, we obtained indole substituted at position 3, and also indole substituted at position 2 with different groups like methyl, ethyl, and phenyl. And also we found that this work is not limited to synthesizing indole only, but we can use it for the synthesis of benzoindole or azaindole. In other words, we can call it pyrrolopyridine. It is really interesting that we found that cyclization of compound 1E is ratio selective reaction, which means that amination occurs for the CH bond at position 2 in pyridine rather than at position 4. Not rather than, but more than position 4. Even it is known in heterocyclic chemistry that position 2 in pyridine is more electropositive. We found also that this reaction is tolerant to a variety of functional groups present on the benzene ring, including electron-donating groups such as methyl group and methoxy group, and electron-attracting groups such as chloro, bromo, fluoro. And it is also interesting to note that cyclization of compound 1H was not ratio selective at all, because it gives two positional isomer of indole in equal amount or in equal ratio, almost 50-50%, which means that the amination occurs equally for the CH also to chloro group and para to chloro group. Among all the tested substrate, only 2 substrates failed to give the indole product. This substrate first one is compound 1K, which have a highly powerful and strong electron donation.